Okay, the last set of exercises, tables for approximating limit. In the last group, we had the graph, so we could really look at the graph and visualize where it was heading at that value. The idea for tables is if we don't have the graph, but rather we have the expression or the equation, or maybe the graph is too confusing, we can always use really kind of plugging in and checking that limit behavior. So let's look at our first question here. Given the function h and asked to estimate the limit as x approaches -8, 3 students created tables. So each table is accurate, but which one is the best for approximating the limit? So we have the limit as x approaches -8 of our function h of x. So I know that if I want to find the value of the function at -8 using the limit, I need to choose some values to the left of -8 and some values to the right of -8. So I know my table should kind of be centered at -8 and should have values to the left of -8 and to the right of -8. I don't want to get too far away. If I'm looking for values at -8, then knowing what the function is doing at +4 isn't going to help. So really we want to stay pretty close to that -8. So over here to the right, I might think -7, -6, but I don't really want to go too far past that. And here, -9, maybe -10 would be as far as I go from there. Now, and then I would choose values getting close. So -10, -9, -9.5, or excuse me, -8.5, -8.1. And then on this side, -7, -7.5, -7.9, etc. I want to get closer and closer and closer to that. So I should see my table kind of approaching that value that we're looking for. So if we look at this first one, -7.99, -7.95, -7.9, that's getting pretty good. And then here, but that's only one way. This is the limit as x approaches -8, but only from the right-hand side. I don't have any values from this left-hand side table. The range of option B is far too large. -14, -12, -10, -2, -4, -6. Even though we are approaching from the left and the right, my values are too big to really give me an idea of what's happening at -8. So both A and B don't really work for the limit. C is nice. We have -8.1, -8.05, -8.001. Those are values to the left, but very close to -8. Here, -7.9, -7.95, and -7.99 are values to the right of -8. And we can see that right in the middle, -8 would fit, and that the values that we have to the left and right aren't getting very far away. So it is really telling me about the behavior that I could expect at -8. On question 2, it's asking about whether a table is appropriate. So again, we want those things. If I'm looking for the limit, it should be centered at my value, in this case, -7. And then I should see values to the left, so a little bit less than -7, and values to the right, so a little bit more than -7, but we don't want to go too far away. So we don't want to go to 5, or even really -10 would be too far. We really want to be really close to our -7. So here, -7.1, -7.01, -7.001, those are all great. These are all great values for that. But then, +7.001, +7.01, +7.1, these are terrible. To find the limit as x approaches -7, these values are way too far to the right. And they're not even approaching our -7. So that doesn't work. Is it an appropriate approximation? No. The table is not appropriate. It does not contain x values from both sides of x equals -7. It technically does. These are to the right, but the x values approaching from the right shouldn't be positive. That one works. Let's see if there's another option too. Let's make sure we check all of our options. No. C is the right answer in this case. The values to the left are fine, but the values to the right shouldn't be positive. If you're looking for -7, they should be around -7. So you're just looking at those tables. Is it centered on your value? And you want some to the left, some to the right. Okay. So our next exercise is going to be estimating limits from tables. So now that we have figured out how those limits are made, let's estimate the limit. So what we're going to do is look at the pattern that we see from the left, look at the pattern that we see from the right, and see, is there a value that kind of fits, that completes that pattern for both sides? So let's look at that. Here's our pattern. The function is defined over the real numbers. We want to find a reasonable estimate for the limit as x approaches 0. So if we look at this table, 0 would go right here, and here we have some values to the left, -0.1, -0.001, so we want to read this one in this direction. And here we have some values to the right, so we're going to read in this direction. -3.9, -4.6, -4.91, -4.01, -3.26, -3.1. If I was to think, I would think this side goes to -5 and this side goes to -3, but those do not equal each other. So I would have to conclude that this limit does not exist. There is no reasonable estimate for these values, because there isn't a value in between that they would go to. So E, because as I go from the left to the right, my answer does not match. Here, we have this table. What is a reasonable estimate for the limit as x approaches 3? So we're looking for the limit as x approaches 3 for f at x. So you can see right here in the center of our table would be 3. 2.9, 2.99, 2.999. Those are values that are less than 3. 3.001, 3.01, 3.1. Those are values that are bigger than 3. So we want to see, as I read this, what values do we get? So 9.6, 9.8, 9.99. I would think the next value there would be 10. 9.6, 9.85, 9.99. 10. So what I think would fill in this gap is 10. The limit as x approaches 3 would be 10. So let's see if we can match that. In our answer choices, 10. 9.9 might be enticing as well, but we got 9.99 already. So the next logical step would be 10. All right. So again, following the tables, just reading them again. Relatively simple concept, the limit. Let's look at our very last exercise, which is just one-sided limits. So remember, we're only going to look to the left or the right for these. We're not concerned with both sides matching up, just what we would get from one side. So here we go. What is a reasonable estimate for the limit as x approaches -5 from the left? So the limit as x approaches -5 from the left. So here's -5. We want to look at the left. So we want to look at smaller values. Or look at values smaller than -5. So that would be these. These are the smaller values. 6.04, 6.0004, 6.00. The closer I get to -5, the closer I get to 6. So from the left, the reasonable estimate would just be 6. So again, just reading the table, but now we are only focused on one side. Here, it is the limit as x approaches -7 from the right for our function h of x. So if we're only looking at values bigger than -7, I can ignore really all of these. For this particular problem, the left-hand side of that table doesn't matter because those are values smaller than -7. We want only from the right. And so we can even ignore -7 itself. It has nothing to do with the limit. So we want to look. We have -497, -664, -830. -830 is the value at -6.9, but it's not what the pattern suggests. The closer I get to -7, I keep getting this big gap in values. Look at it. That's a very, very tiny change in x. You went from -6.996 to -6.999. One more step wouldn't give me -830 again. I would expect a bigger jump. In fact, this would lead me to believe that this graph is going to -infinity because I do not see a pattern of approaching values. It's not getting closer and closer to 10. The number is just getting, the value is getting bigger and bigger, although negative, so the number is getting smaller. But, so in that case, -infinity would be our answer there. Reading that table from one side, let's see if we have unbounded. There it is. Okay. All right. Okay, guys. So that is it. Tomorrow, I will post one or two more tests. I'd have to look at my planning sheet to see how many more. But that is the last thing I will post work-wise for this year. This is the last video I will post for this year unless more help is requested. If you need assistance, please email me. If you need any help at all, I can set up Google Meets to go over some things if you really need help there or just need me to answer a question about an assignment. But otherwise, tomorrow everything will be posted. Khan Academy is already posted And Google Classroom, you'll look for 1 or 2 more tests to take. Once you get those done, you are done with pre-calculus. I want to say it's been a pleasure teaching you guys this year. I'm sorry that we had to end up the fourth 9 weeks this way. I hope everybody is staying safe and as positive as can be during this time. If I don't see you next year, good luck in your future endeavors. And if you're on campus next year, if any of us are on campus next year, stop by and say hi. But otherwise, have a great summer. See you next time, guys.